All right, welcome to the next section of 4.1. So we just talked about injective functions, which is where every single input goes to a different output. So no two inputs go to the same output. This leads us to a very logical next step, which is what is the inverse of a function? So we know that a function is something that takes inputs to outputs. Basically, the inverse of a function kind of reverses that process. It asks, okay, we've got this function that takes inputs to outputs. What would be the equation or function that takes those outputs back to the inputs? And so in other words, it's an inverse. It kind of switches the domain and the range. So unfortunately, the notation of an inverse function is f to the minus 1. And that's a little bit confusing because, as you know, when you have a negative exponent, if it's just on a variable, it means 1 over that, right? You put it in the denominator, but that's not the case here. So f to the negative 1, when we're talking about functions, does not mean 1 over f. It just means the inverse function. So try not to confuse the two. All right, so how do you find an inverse function? Let's look at this right here. We have y equals 3x plus 12. It's very easy to find the inverse of a function. It's two steps. Step 1, you flip your x and your y. Just like that. So do you see that all I did there was I just traded my x and my y? Then the second thing you do is you solve for y. And once you do that, you have your inverse function, and you're done. Now, why does it kind of make sense that we flipped x and y? Remember, we're trying to find the inverse of the function, which is like the function backwards, where we take outputs and get to inputs instead of the other way around. So let's solve this for y. Start by taking off 12 on both sides. Okay, that's going to give us x minus 12 is equal to 3y. And then finally, you divide by 3. And remember, we need to divide all of this by 3. So we've got y by itself, so I'm going to write the answer like this. Y is equal to, I'm going to go ahead and distribute this 3. So that's going to be 1/3 x, or x over 3. And then minus 12 over 3, and 12 divided by 3 is 4, so minus 4. So this function right here, 1/3 x minus 4, is the inverse of 3x plus 12. This takes x to y's, and this would be taking y's to x's, if that kind of makes sense. So let's do another example. Let's find the inverse of this function. It's going to be basically the same thing. Remember the two steps. So first, by the way, if instead of y here it said f of x, what you should do is go ahead and scratch off f of x and just write y. Because remember, the first step is to trade x with y. Just like that. X equals y squared plus 3. And so it gets confusing if you have f of x in there. So flip x and y, and now just solve this for y. So first we would subtract the 3 over. And so I have x minus 3 is equal to y squared. And how do we get y by itself? You just take the square root of both sides. So take the square root of this, take the square root of this, which gives us a final answer of y is equal to the positive or negative square root of x minus 3. Now, you notice that I wrote positive or negative, and that's because I can't have both, because if I had both at the same time, it wouldn't be a function anymore. So I'm guessing on your homework that they're only going to want the positive answer, that the inverse of the function is y equals the positive square root of x minus 3. So if you're getting it wrong on your homework, that's what I would try to do, only putting in the positive. You'll notice that the inverse of a square is a square root. And that should kind of make sense because they're kind of the opposites of each other. Let's do this one. What is the inverse of y equals 1 over x plus 3? So on this one, let me straighten out my paper. Again, the first step is to flip x with y. So x equals 1 over y plus 3, just like that. And now what we need to do is solve for y. So you notice that we have y in the denominator of that function. So let's multiply both sides of the equation by y plus 3. This gets rid of our fraction. Okay? So this entire denominator cancels with the y plus 3. That's why we did that. So I get y plus 3 times x is equal to 1. So far, so good. Now we still need to solve for y. So that means getting this y by itself. So let's go ahead and, in fact, here's what I'm going to do now. I'm going to do something kind of tricky here. Rather than go ahead and doing the distributive property, which I could do if I wanted to, I'm going to do something clever, and I'm going to go ahead and just divide by x right now. Because do you see that that would just move the x over? So let's go ahead and divide by x on both sides, because that cancels our x's. So we get y plus 3 is equal to 1 over x. Do you see how I did that? So I divided both sides by the x's because I didn't want to get the x inside of here because y is already by itself over there. So now we're just one step away, just subtract 3. So how do you do 1 over x minus 3? Don't overcomplicate it, just write it as 1 over x minus 3. So the answer is y equals 1 over x minus 3. And there you go. So notice how these two are kind of similar. 1 over x plus 3 and 1 over x minus 3, but only the x is in the denominator instead of x plus 3. There's something really special about these two, or these two, or these two, which I'm going to show you in the next section. Now let's do this. We've got y equals the square root of x minus 2. By now you know what to do. First, swap your x and your y. Just like that. And now we just solve this for y, and then we have our inverse function. So how do we get rid of this giant square root? We have to square both sides. So square both sides, and you get x squared is equal to, again, we squared this side, square this, and when we square the right-hand side, the square cancels the square root. So we're just left with y minus 2. Isn't that nice? So go ahead and add 2 to both sides, and we're done. Because we want to get y by itself. So the negative 2 cancels the positive 2. And so we get, I'm going to write y first. Y is equal to x squared plus 2. So that's how to find the inverse of a function. Notice it's just 2 steps. Flip the x and the y, and then solve for y. Also remember that it can be a little bit confusing. So on this example right here, I could have written f of x is equal to x squared plus 3. All right? And the way we would write the inverse function is we would say f to the negative 1 of x is equal to the positive square root of x minus 3. Or if you want to get technical, the positive or the negative, because you need both halves of that. But you can't have both halves at the same time, or it won't be a function anymore, because it won't pass the vertical line test. So that's how you would write it. F of x equals this. F to the negative 1 of x equals the inverse function. And remember, this doesn't mean 1 over f. It just means that the inputs and outputs kind of get replaced. This is kind of this function backwards. So I hope all of this makes sense. You notice again that a square became a square root, and a square root became a square. And there's something really special about functions and inverses, which we will see in the next part, and I will see you there right now.